everyone. So today we're going to talk about the characteristics of stars, and our essential questions for this lesson are: how are stars classified? How do astronomers measure distances to the stars? And what is an HR diagram, and how do astronomers use it? So we're going to check back at the end of the lesson and make sure that we answered those questions. For your warm-up, we have two questions, and you need to tell me if this statement is true or false, and if it's false, tell me why. The brightness of a star depends on its size and temperature. And number two, a light year is a measurement of time. So pause the video and tell me what you think. So you think that those statements are true or false, and why do you think that? Okay. So constellations are imaginary patterns of stars, and they form what sort of look like pictures in the sky at night. And there's a whole bunch of different constellations with different names. Characteristics that are used to classify stars are color, temperature, size, chemical composition, which is the elements that are found in the stars, and that's determined using a spectrograph, which is something that breaks the light into colors, which produces an image of the resulting spectrum. And by looking at those spectrums, then we can compare them to the spectrums for different elements, and that tells us what elements are found within the star. Brightness of stars depends on both its size and its temperature, and we sometimes refer to brightness also as magnitude. So those two words are used interchangeably, brightness and magnitude. And they depend on both the size and the temperature. Apparent brightness or apparent magnitude is the brightness as seen from Earth. And absolute brightness or absolute magnitude is the brightness of the star as if you were at a standard distance from Earth. So if each star were at a standard distance from Earth, that would be the absolute magnitude. And here's a picture of the temperature of stars. It's a diagram in your notes for you to draw. And the thing about the colors as they relate to temperature is that it's a little bit backwards from what you would probably estimate. So the hottest stars are blue and the coldest stars are red. And you can pause the video right now if you need to in order to draw the diagram. Okay. A light year is a unit of measurement used to measure distances between stars. A lot of people confuse light year, which is used to measure distance. They'll confuse it with thinking that it's used to measure time. But light year is used to measure distance, and it is the distance that light travels in 1 year, which is about 6 trillion miles. Another way that distance is measured is using parallax, and parallax is a way of measuring the distance to nearby stars. And it is the apparent change in position of an object when you look at it from different places on Earth. And to get a little idea of what parallax is like, it would be like taking your thumb, okay, and putting it straight out in front of you towards the PowerPoint or towards the video, and then closing your right eye and looking with your left eye. Noting the position of your thumb and then switching so that you close your left eye and look with your right eye. And you'll notice that your thumb seems to move even though you didn't move your thumb. So that's an example of how parallax works. We look at the position of a star from different positions on Earth. The Hertzsprung-Russell diagram, which we will do a little more practice with today in class, was created by Hertzsprung and Russell, and they made a graph to find out how the characteristics of stars, both temperature and absolute magnitude, are related. And you'll notice when we look at the diagram that there is a relationship that we can categorize. We use the HR diagram to classify stars and to understand how stars change over time. Now, the majority of stars in the diagram form a diagonal line called the main sequence. And more than 90% of stars, including the sun, are main sequence stars. And stars that fall in that main sequence category, basically what happens is as the temperature increases, the brightness increases. But there are stars that fall outside of that category, as you can see, if we look at it a little bit closer. So I would like you guys to look at the Hertzsprung-Russell diagram and notice this is the main sequence, which is where most of the stars fall. Now, the one thing to take note of here, if you can see it, is that the x-axis and the y-axis are a little bit different than what you would normally see on a graph. So first, let's look at the y-axis because that one is more normal. So this one shows an increase in absolute brightness or absolute magnitude, which is also called luminosity, okay? So as you go increasing up the y-axis, that brightness increases. So that makes sense. The difference here is that we're looking at the surface temperature, and the surface temperature actually goes from hot to cold as you travel along the x-axis. So you're going from 50,000 Kelvin down to 3,000 Kelvin. And that is really the thing that trips people up about the Hertzsprung-Russell diagram, is that the x-axis is backwards, because normally you would see an increase in temperature as you're looking at the x-axis. Okay, so quiz time, get ready, number 1 through 5, and we're gonna go and check and see what we got from today's lesson. So question number 1, a star's brightness as if it were a standard distance from Earth is known as what? A star's brightness as if it were a standard distance from Earth. It's sometimes called absolute magnitude or absolute brightness. A unit, number 2, a unit that is often used to measure distances between stars. What is that called? A unit that is often used to measure distances between stars. That would be a light year. Okay, we talked about this at the beginning of the lesson. What is an imaginary pattern of stars? A constellation is an imaginary pattern of stars. The brightness of a star as seen from Earth is called what? Make sure you pause if you need a moment to try to figure that one out. That's the apparent brightness or the apparent magnitude. So absolute magnitude and apparent magnitude, a lot of people get tripped up with. So if you're getting tripped up with that question, make sure you go back and read it again or watch the video again. And which of the following is not a characteristic of stars? Size, temperature, texture, color, or chemical composition? Which of the following is not a characteristic of stars? And the answer is texture. So let's look back at our warm-up. And in our warm-up, question number 1 said the brightness of a star depends on its size and temperature. And that is true. A star's brightness depends on its size and its temperature. Generally, the warmer or hotter a star gets, the brighter it gets. And question number 2 is false. A light year is not a measurement of time. A light year is a measurement of distance between stars. It's the distance that light travels in 1 year. And do you remember what the distance is that light travels in 1 year? If you don't remember, go back. Let's go all the way back. Scroll, scroll, scroll. Scroll. And where is it? Close your eyes if you're getting dizzy. Do you remember the number? 6 trillion miles. 6 trillion miles is the distance that light travels in 1 year. Okay, so let's look at our summary, which is the last thing you need to do to prepare for class. And at the bottom of your Cornell notes, there's a place for you to write a summary. And if you go back to your essential questions, you can use the essential questions to help you write your summary. So the 3 questions we are looking for are: how are stars classified? Stars are grouped together based on what? How do astronomers measure distances to the stars? What are some ways that we can measure distance from one star to the next? And what is an HR diagram and how do astronomers use it? The HR diagram is used by astronomers to do what? And you just need to write that in your summary underneath your notes. So that's all for today's notes on the characteristics of stars, and I will see you all in class. Have a great day, and I'll catch you next time.